Hi, welcome back. In this lecture, I want to give you a brief overview of the preparation work we need to do in order to implement our first OpenGL application. This lecture, I will focus on 4 main points. First, OpenGL doesn't include window creation and management. For this reason, we will need separate libraries to manage the windows. Second, as window creation and management library, we suggest that you use either GLUT, FreeGLUT, or GL/FW libraries. Third, GLUT, FreeGLUT are easy to use and likely already installed on your system, while GL/FW is more modern, but you need to install it. Finally, when using an OpenGL, you need to install and use a library for function pointer management. We suggest that you use GLAD. Before we can start drawing things, we need to initialize OpenGL. This is done by creating an OpenGL context, which is essentially a state machine that stores all the data related to the rendering of our application. When our application closes, the OpenGL context is destroyed and everything is cleaned up. The main problem we have is that creating a window and OpenGL context is actually not part of the OpenGL specification. This means that it is done differently on every platform out there. Developing application using OpenGL is all about being portable. So for this reason, OpenGL cannot support a window creation and management system. Luckily, there are libraries out there that abstract this process. So then we can maintain the same code base for all supported platforms. In this lecture, we are going to look at briefly at 2 libraries for doing this. While the available libraries out there all have advantages and disadvantages, they do have all the certain program flow in common. We start by specifying the properties of the windows, such as the title and the size, and the properties of the OpenGL context, like the aliasing level. Our application will then initiate the render loop, which contains an important set of tasks that need to be completed over and over again until the window closes. These tasks usually handle window events like mouse clicks, updated rendering state, and drawing. There are quite many libraries for window creation and management. Among the others, we suggest that you choose between using GLUT, FreeGLUT, or GL/FW. You can use OpenGL Utility Toolkit, GLUT. That is a library that is probably the easiest one to use. It is already installed on the lab machines and likely installed already on your laptop. The problem is that GLUT was not designed to work with the modern OpenGL. The original GLUT library has been abandoned, with the most recent version dating back to 1998. Its license does not allow anyone to distribute modified library code. For this reason, FreeGLUT was developed. The second library is GL/FW. That is a C library specifically designed for a core profile OpenGL application. It comes with window and context creation and the input management. It's the most modern library for window creation and management, and it has the best integration with modern OpenGL. This is likely to be the only slide I'm presenting with the GLUT. In fact, I'm using GL/FW in my example, but we do provide example code using GLUTs. So looking at the code, we look at the main function code that will initialize GLUT and create the window. After that, GLUT enters the render loops and it gains control of the application. GLUT will wait for an event to occur and then will check if there is a function to process. An event is something like a key pressed, a mouse move, a window that needs to be painted. Before GLUT enters its render loop, we need to tell which function GLUT must call for each event we care to process. Telling GLUT which function to call back when an event occurs is called registering the callback function. For each event type, GLUT provides a specific function to register the callback function. There are 2 things left to do before we are ready to render something. The first thing is to tell GLUT what is the function responsible for the rendering. This function will be called by GLUT every time the window needs to be painted. Let's tell GLUT that the function render scene should be used whenever the window requires to be painted. GLUT has a function called GLUT display func that takes as a parameter the name of the function to use when redrawing is needed. Finally, we also need to tell GLUT that we are ready to get in the render loop. GLUT provides a function that gets the application in a never-ending loop, always waiting for the next event to process. This GLUT function is called GLUT main loop. To use glfw instead of GLUT, you will need to download it and install it on your system. You can follow the instruction line. You can just check the website following the link on the slides. If you build it from the source instead of using the binaries provided on the website, you will need to use the CMake building system. I will go into details of glfw, window creation and management in the next lecture, so I'm going to skip the details of the code presented on these slides. You might have noticed that GLUT function, GLUT swap buffers and glfw swap buffers. But what do they do? Well, when an application draws in a single buffer, the resulting image might display flickering issues. This is because the resulting output image is not drawn in an instant, but drawn pixel by pixel, and usually from the left to the right and from the top to the bottom. Because these images are not displayed at an instant to the user, but rather via step-by-step generation, the results might contain quite a few artifacts. To circumvent this issue, Windows applications apply a double buffer for rendering. The front buffer contains the final output image that is shown at the screen, while all the rendering commands draw to the back buffer. As soon as all the rendering commands are finished, we swap the back buffer to the front buffer, so the image is instantly displayed to the user, removing all the artifacts. We are still not quite there yet, since there is one other thing we still need to do in order to use OpenGL. Since OpenGL is a specification document, it's up to the driver manufacturer and implementers to implement the specification to a driver that a specific graphics card supports. Since there are many different versions of OpenGL drivers, the location of most of these functions is not known at compile time and need to be queried at runtime. So it's often our task of the developers to retrieve the location of the function. And for this reason, we need to store them in using function pointers for later use. Retrieving those locations is OS specific, and it looks something like the code in these slides. As you can see, the code looks rather complex and is a rather cumbersome process to do this. For each function we might need that is not declared. Thankfully, there are libraries for this purpose. GLAD is an open source library that manages all the cumbersome work we talked about in the previous slide. GLAD has a slightly different configuration setup than most common open source library. GLAD uses a web services where we can tell GLAD for which version of OpenGL we would like to define and load all the relevant OpenGL function according to that version. So go to the web service, make sure that the language is set to C++, and in the API section select an OpenGL version of at least 3. Also make sure that the profile is set to core and that the generate loader option is ticked. Finally, click on Generate to produce the resulting library files. GLAD provides you with a zip file containing 2 include folders and a single glad.c file. Copy both include folders, glad and khr, into your includes directories, or add an extra item at the compiler time, pointing to these folders using the -i flag. Finally, add the glad.c file to your project. So, in summary, in this lecture I focus on 4 main points. First, OpenGL doesn't include window creation and management. For this reason, we need separate libraries to manage the windows. Second, as window creation and management library, we suggest that you use either GLUT, FreeGLUT, or glfw libraries. Third, GLUT and FreeGLUT are easy to use and likely already installed on your system, while glfw is more modern, but you still need to install it. Finally, when using OpenGL, you need to install and use a library for function pointer management. We suggest that you use GLAD. In the next lecture, we will code together our first window creation with glfw and GLAD. Talk to you soon!